Hello, everybody. My name is Zineb Amrani. I'm very happy and very honored to be here. Thank you so much for having me. I work at Facebook, and this is basically all the contact information that I use. Please feel free to reach out to me with whatever questions you have. Little spoiler, this talk is not really technical about artificial intelligence. It is more about data science, and what I mean by that is how you make the technical skills meet with domain expertise. Our host this morning made a lot of insisted a lot about how domain expertise was very, very important in order to transform your knowledge into something that is actually useful and making the world better. You have a goal. For example, the talk about healthcare this morning was about just making healthcare more accessible and more cost effective, and how you can make sure that when you develop your products, your AI products, you are able to develop them and improve them in the right direction. What I mean by a product here is basically anything that is a solution to a problem for a customer. Hopefully, I can talk to you about how at Facebook, where I work, we think about product development and how we leverage measurement, data, metrics, and other analytical frameworks to make our products successful. So I will be sorry. In this talk, I will be talking about how you can structure product development around the data and data science. The importance of goals and long-term vision. This is where your domain expertise is going to be very important. And then other key analytical tools and frameworks that I would encourage you to use as you are building products. Is anybody here building products? Raise your hands. Yeah? Hopefully this is going to be useful to you. If not, just throw tomatoes at me. The way we structure a team, and this is just one example. By no means am I saying this is the only way to structure a team, but hopefully will help you understand how what I will talk about in the rest of the presentation is usually you have engineering or like developers, software developers, machine learning developers, AI developers, and they are the ones who will be writing the lines of codes. The lines of codes of your conversational AI that decides like when to start a conversation, when to pursue, and what to say, for example. And then you would have designers, and this is like the canonical example here is when you're building an interface. A designer is the person who's going to think about the use cases, the different types of people and type of use cases that your interface is going to have to solve for, and they will just inform the product strategy with their expertise. Product management. So the product manager is usually kind of the maestro of the orchestra, the conductor. It's the person who will make sure that all these functions will work together in harmony and deliver towards the goal of the product. And then there's analytics. And analytics is where you would have data science, measurement science, and I mean, the titles, they differ from one company to another, but this is like the person or the team that is responsible to collect the data, to pipeline it into data sets that are easy to query and easy to use, and then to measure the progress that the product is making towards the goal and the problem that you're trying to solve. One of the expressions that we use a lot is empathy at scale. So data, when you collect it, helps you understand the problems and the pain that users have. This is one typical example that we have at Facebook, is just like groups. If you're familiar with groups, it's just like you can create a group on Facebook and interact on the group page with just a member of that group. So it could be an open and a closed one, etc. When we developed that, we did not necessarily think about the fact that people will be buying and selling stuff on Facebook. So you open Facebook and you say, I have a car to sell, or I can give math lessons, and I sell them on the platform. So one of the things that we've done is making sure that we had buy and sell groups. So that was the first step to solving for that problem, where people were just like kind of using Facebook to buy and sell stuff. And then as we improved, we realized that people didn't even connect to groups anymore to buy and sell. They would just like go to the search bar and say for sale Islington. Islington is an area in London. And they will look for stuff to buy or sell there. This is like by understanding this type of problem with empathy at scale that we developed Marketplace. So you don't need a group anymore to go and buy and sell stuff. So this is just hopefully one example that will speak to you. Now, your responsibility as you are building a product is to make sure that this product is going to serve your domain and is going to leverage the expertise of your domain to solve a problem that is important. This is why long-term goals are important. And a long-term goal comes usually with a metric, which is something that is measurable. My tip to you is do not start building a super deep algorithm, NLP, neural network, whatever, without bearing in mind what is it that you're solving for, and without measuring the progress against what you're solving for. So we care about metrics. It's because they connect the product vision with something that is measurable, and it allows you to track progress against the metric. It maximizes the team's potential, and it helps you prioritize work. It motivates the individuals and the teams, and it also gives you just a measurement of success and recognition, which is also super important when you're building a product. So how do you pick a metric? So this is like an example here. So one of the missions that we have at Facebook is to help you find your friends online and connect with them. Now, one way that we can do that is, and I'm sure that you've seen this, sometimes when you connect on your page, you have suggestions of profiles of people that you may know. So this is like kind of a machine learning AI-based algorithm that just tries and predicts whether two profiles that exist on Facebook are actually friends in real life, and we're trying to connect them on the platform. Now, if I go and speak to the engineer or the data scientist or whatever the title of the person who's developing that model and tell them what you're optimizing for, they're going to tell me something like, some precision, recall, some error function that they want to minimize. Fine, this is good, but this is not the goal. This is not how you're going to make something useful. So how do you know what is a good enough precision? What is a good enough recall? What is a good enough loss function? You're going to know it if ultimately that recommendation of friends is going to help you achieve your mission and your goal. So you want to help people find their friends online. You want to increase the friendships created on our platform, so like people that friend each other. And one metric that you can think about in order to track, in order to track that is number of friendships accepted, let's say in the last 28 days. And you can set a target to that, like kind of an ambitious number. Now, you've set up your goal, your metric. What could possibly go wrong? Well, actually, a lot of things. It is super important whenever you set your metric and your goal to ask what is it that you're doing to achieve the goal, and what are the cases where you kind of not really achieving your goal. In this case, if people start friending each other but they never talk, it's not really valuable, right? We don't just want to create pairs of friends in the platform if it's not going to create more engagement and more opportunity for social interaction. This is where I would encourage you, whenever you have a goal, to think about the things that, the counter cases that look good, but actually are not serving your goal. one of the examples here is like you don't want to only increase the number of friendships, but like meaningful friendships. This is just a word, right? How do you really measure something meaningful? So one suggestion here is number of friendships accepted in 28 days that actually leads to an interaction, like a message or a share or a like or something like that. Your target is still the same, but you think of counter metrics. So you want to increase number of friendships, but you probably want to look out for the number of blocks or people who unfriend each other, or even the rejected requests. So like people send you requests, but actually you reject them. All good so far? Yeah? People nodding in the audience? Cool. Now experimentation. So you have your metrics. Whenever you're developing adding a new feature or developing a different use case for your product, you want to experiment and make sure that this is actually making your product better. And making your product better means that it moves you closer to your goal and the target of that metric that we've set up before. Experimentation is one way that you can understand at scale that helps you actually make the right decisions, because data collected through your experiment wins arguments, and assess the impact of your work. Impact of your work means how much you move the metric that we talked about. However, it's not always possible. So there are cases where it is recommended or you actually cannot experiment. There are multiple cases. Those are just examples here. Sometimes there's a risk angle. So if you start experimenting on the Facebook platform, then you may have some unfair treatment of your users. So some users see one nice, cool feature and some others don't. This is a PR problem. But sometimes you also have measurability challenges. So if you have a product that is going to change a behavior by a teeny tiny bit, or it's going to change it reasonably, but for a very, very small volume of users or use cases or whatever, then this is a case where it is actually hard and not recommended to experiment. But when you can experiment is when you can actually, like before experimenting, you ask yourself, if I knew the answer, like if I have two groups and I know which one is better, is that going to really allow me to make a better decision? And how would my product, like it will give me ideas to make my product better. And the questions that you're gonna ask before you set your experiments are based on intuition, personal experience, and product expertise. I promise I did not change this after the talk from Beyond Limits this morning. Domain expertise is what is going to make you successful as a data scientist or as anyone who is building products that leverage data. It will come as well from observational analysis, so just like asking people what product changes they're expecting as you develop. Before experimenting, you'll have to enunciate good hypotheses. A good hypothesis is simple, specific. Sorry, did not move. Simple, specific, single-barreled. Provable or falsifiable, and actionable. So it really drives a decision as a result of your experiment. A bad hypothesis is something like ads on Facebook affect user engagements and sentiment. Why is that a bad hypothesis? Because like, what do you mean by ads? And what do you mean by user engagement? And what do you mean by sentiment? And it's going to affect it in which direction? It's too vague. There are too many things in that hypothesis. A good hypothesis is users with privacy concerns will upload fewer photos. This is a simple, a specific hypothesis because you have an effect, uploading less photos, that is quite simple to measure. And it's you're targeting a set of users with privacy concerns. Now, let's say that we want to experiment against that hypothesis. So the question that we're asking, that we're willing to answer during this experiment is, are privacy concerns affecting content production? Privacy Checkup. So Privacy Checkup is an AI that we have that talks to you as you are uploading content, and that makes sure that you understand who's going to see that product and that you can change the settings according to your concerns. I'm going to show an example later. Thank you. I have 10 minutes left. I'm going to hurry. Privacy Checkup, the hypothesis that we're going to test is that they will alleviate privacy concern and it will increase content production. How are we going to measure that? How are we going to prove or falsify this hypothesis? We're going to randomly assign privacy checkups to some users, survey them later about privacy concerns, like just ask them, do you feel better about your privacy on Facebook? And measure their content production. Here's what privacy checkup looks like. It's just a little robot that talks to you and say, hey, sorry to interrupt. I just want to make sure that you understand who's going to see your content, etc. There are different experimental approaches. As I said, sometimes you cannot always have a random sampling or A/B testing experiment methodology. A few of the things that you can use when randomization is not available: observational analysis. So people who use stickers, you know, those cute little things in Messenger, have more messages sent. This is interesting. Sometimes it is really hard to prove causality, but if you don't have any other choice, then you have to start with this and find a way to prove causality. You can have a before-after measurement. So you ship a new feature or a new functionality of your product, and then you see what has changed. Sometimes you'll have to correct for seasonality or for other effects that could be correlated, that could have happened at the same time of your change. Randomization, this is like A/B testing. So you have a random group that will have stickers and random groups that doesn't, and you'll observe a difference. If we are to go with randomization, you have to start with the people and a targeted audience. You split them in version A and version B, like two groups, one that will see one version of your product and one that would see another version of your product. And it's super important that you log who is in which group and that you log the metrics that you want to observe. Some common mistakes that you have when you experiment. Selection bias. Sometimes the groups that you are choosing to compare against one another have something that is correlated with the metric that you're trying to change or to observe. Be aware of that. Second one is network effects, especially relevant for Facebook. So if I am connected to you and I have a new feature like stickers and you don't have it, and I send you a message, you're just like, ooh, what just happened? So I've just polluted the other group if you are in the control group and I'm in the test group. Be careful about this. Ecosystem metrics. So if I am in Messenger, I want to increase the number of messages that are sent, but how does that affect the other metrics that Facebook cares about? The active users, the time spent in the platform, etc. Always ask this question. Novelty effects, especially if you're talking about B2C products that just have a nice fashion vibe. If there is something new, everybody will use it for 3 days, your metrics will pick up, and then everybody will forget about it because it's not a product that actually sticks. It may not be a product that actually sticks. And the last one is just another way to say that it's important to have a top-line metric. Plan for your test. Plan for the hypothesis that you are trying to prove or to falsify, and be sure what you want to measure. Don't just test, have your randomization and just go and see that metric went up and that metric went down, and now what do I do? Okay, so I think I have just a few minutes left, so I'm going to go super fast on the rest. Some of the key questions that you have a responsibility as a domain expert to ask about your product. They may not always be relevant for all the products, but those are examples that will be that I encourage you to at least consider them and see whether they're relevant for you or not. The first one is the funnel. So the funnel is just like this is an example of a buy and sell funnel in a e-commerce website. But it is relevant for every product that has multiple steps before you achieve the things that you want to achieve. So before achieving a buying action in a website, people will have to visit the homepage, browse the categories, view the product, etc. And there is less and less people at each step of the funnel. Understanding the funnel just gives you an opportunity to understand the drop-offs, like why do people complete or not complete the funnel, and diversify your product offerings. Another example is the growth accounting. So if at Facebook we are trying to increase the daily active people, we try and understand whether there are new users just logged on the platform for the first time, retained users, they come back every day, resurrected users, they hadn't used it in a while and they've come back, or churned users, like they're not using the platform and they're not going to use it anymore. Super important because it just informs your product health, your growth stages, acquisition versus retention strategies. So if you want to increase the number of new users or just retain your user, depending on how your growth accounting looks like. And also whether we are putting people into a leaky funnel. This is something to be aware of. How many people get in and how are they likely to go out? I have an example that I'm going to skip in the interest of time, but please come and grab me later and ask me all the questions. Some other examples of questions that you have a responsibility to ask about your product. And because hopefully your products are leveraging large amounts of data, complex data, hopefully it will also give you kind of a learning ground for new techniques for analysis and statistics. When does your product fail and why? Super important. Who are your power users and why? What makes somebody want to use your product all the time? Ecosystem and other system metrics, like we've talked about this. How does your product impact the use of other products? And the make of a good data scientist is to be able to generate and answer, that's the hardest part as well, many of these relevant questions. I am also gonna skip here, and I will finish with some thoughts so that we have maybe time for questions. These are my tips to you as you are building a product. First, always start with why. What is your goal and what is it that you're increasing or decreasing or moving as a metric? And please don't tell me something technical about a loss metric or something like that. A goal is something that serves the problem that you are, that serves solving the problem that you are solving. So start with why, and as I said earlier, follow up with why not. Like, okay, so I have my goal and my metric, what can go wrong? Of course, I don't need to say that I'm preaching to the choir here, but like log, sparingly if needed, depends on your infrastructure, but log everything that you need to measure your metric, your experiments, and pipeline your data into easy to query data sets. Invest as much in knowing your field, your audience, your customer, as in developing technical skills. As it was said this morning, technical skills, they are textbook skills. They are available in online courses. They are available in open source codes, libraries, etc. The domain expertise, what you know of your field, is what's going to make a difference for you as you are building highly technical products. encourage diverse perspective. One way that you can do that is just share your insights across to everybody that you know, and just get their feedback about the product, about what they see is useful, what is not useful. It's very important. And the last one is probably why I'm standing here: invest in soft skills. So you may have all the data in the world, you may have the best work in AI. If you're not able to show to the people that it's going to be useful for them and solve their problems, if you're not able to communicate that, then it is going to be a failing product. So invest in soft skills communication, and hopefully that was my investing here. Thank you so much.